So, today I'm going to talk about the DC hybrid policy, which is a new policy for allocating DCIs. I will continue. Okay.
Okay.
So,
So seems like you suffered bad enough to put the first slide.
yeah. What is a DC transport? I'm sure most of you know what DC transport is. So, to those who don't not familiar with the DC transport, we have in InfiniBand the RC transport, which is the equivalent of TCP in InfiniBand, and it's a reliable connection-based transport. It requires a dedicated QP for each endpoint that you want to send data to. And the issue with it is that it's not very scalable as you have a growing number of EPs. You can understand why a dedicated QP for each possible EP can be limiting. Okay, so the solution is using DC, which allows sharing QPs or transferring QPs from one endpoint to another. When I say transferring, I'm referring to using the same QP to send to different EPs and not sending the QP to another EP. So the idea in DC is it's a datagram-based connection. So different endpoint can use different QPs at different times because an endpoint not necessarily be active the entire execution. So this will be better use or better utilization of the hardware resources. Any questions till now? I think probably not. Okay, so what are DCI policies? So DCI policies determines how DCIs are going to be allocated. 1 second. Okay, how they're going to be allocated, whether EPs can share the same DCI simultaneously, whether they're going to whether they're going to be managed by software or hardware. And one important thing about policies is to avoid starvations of EPs that are waiting for resources, or the other way around, not utilizing efficiently the available resources in that policy. Okay, so current DCI allocation policies that we have. I'll start with the most basic one, which is DCS. The idea is allocating some array of DCIs, and the sharing mechanism between EPs is done using some stack, a LIFO data struct. And each time we're trying to send some data over DC, the endpoint tries to acquire, if it doesn't already have one, some QP, or DCI, which is the same thing, and it looks at the stack top. I don't know if you can see my cursor, but it looks at the stack top and see which DCIs are, sorry, maybe got confused. It tries to allocate, I think it takes from the stack top. Yes, it takes the stack top from the DCI pool. And the stack is containing indices of the DCIs array. So you can see that We also have some release talk for DCIs for EPs that finish to send their data and they can return the DCI to the pool. So any questions about how that works? The issue with it is that after an endpoint acquires some DCI, you can't really know without setting some quota of usage that you are not causing some starvation for other EPs waiting for resources, as DCI pool size is limited. Today it's I think 32 DCIs in each pool, and that's the idea behind DCS quota, is doing the same thing with the sharing using the stack of DCIs, using the pools, just limiting each EP to some quota that after that quota, the endpoint has to release its DCI. One more thing is the idea of using a stack is to benefit as much as we can from the cache. And we also have shared policies, which means two different EPs can use two or more different EPs can use the same exact QP at the same time. One policy is the random policy, which is pretty simple. Each EP is assigned, each endpoint is assigned with a random index of the DCI the DCI's array, sorry. And they just can use it simultaneously, because as long as they can use it simultaneously as long as that QP still has available resources. The idea behind using random policy is that each DCI is selected at equal probability, and the average load is distributed somewhat evenly. Okay, and we also have our device-specific policy. It's probably supported by almost every modern NIC that NVIDIA or Mellanox supplies. It's the hardware DCS. It's actually utilizing the hardware by letting the hardware manage the allocation for us. We are actually creating a single DCI with 256, I think, hardware managed DCI channels, and each EP is assigned to a specific channel, and that's how the hardware know to distinguish between messages coming from different EPs. So in theory, it should be pretty good. We do have some issues with hardware DCS in smaller sizes, that the latency is not great for smaller sizes. So that's why Yossi suggested doing some hybrid mode, in which we are doing the same as DCS quota. We're using DCS quota, but every time we have no available DCIs in the pool, we're using a dedicated hardware DCI. Sorry, a dedicated hardware DCI. Sorry. Okay, so how DCS quota works, and more deeply, we have some send requests for some EP. First thing to ask is whether that EP already has a DCI assigned. If it doesn't have one, we're asking if we can allocate one from the pool. If it can allocate from the pool, everything is great, you're using the one from the pool. Otherwise, you're going to some pending state where you wait until some DCI is released and you can use it. Okay? Great. You hear me well? Everything is okay?
Yeah,
Yes.
I can hear you.
Great. So what is hybrid policy is doing? Oh, wait, I forgot the step. Yes, there was also the step with the quota. If it has, there are cases where this EP has already the DCI, but he already exceeded the amount of data he can send above that DCI. So if the quota wasn't exceeded, you can continue using it. Otherwise, you have to release it and go back to pending queue to avoid starvation, like we mentioned earlier. So wait. Okay, so in hybrid policy, in the case we are asking whether we can allocate from the pool, in case we can't allocate from the pool because all DCIs are already occupied, we are utilizing that dedicated hardware DCI and using hardware DCI simultaneously with the software ones. And we can do that as long as we have enough DX resources in that hardware DCI. The hardware DCI is also limited eventually. Okay. So how do you use different DCI policies if you want to experiment with this? We have some environment variable for that. It's called U6, the DCMLX5 TX policy. You can set the following values. And I like to use protoinfo in order to know that what protocols I'm using. It's nice. And you can also force using DC. In general, I think DC is being used above a certain amount of EPs. But if you just want to test what DC is doing, it's a good way to achieve that if you want just to debug DC. So I did use some all-to-all OSU all-to-all benchmark. One sec. Okay. So I did some all-to-all benchmark. You can see I set the TLS to just DC, to DC shared memory and self. And here I set the policy, probably familiar with all that stuff already. And that's the machine I was using. I was using a Connectix 7 device. So about the results, the hybrid DCS, I was comparing the DCS quota, which is the current default of U6, against the new DCS hybrid, and there is no much effect for DCS hybrid until you get to 32 processes in that benchmark, because the default pool size is 32. So you always have enough QPs for every endpoint. And so no much of effect around there. You start to see a slight improvement in 64 processes and a nicer improvement in 128 processes. And we're comparing latency in microseconds. And I saw that significant difference specifically in that size. Other sizes were boring and pretty much had somewhat the same latency. And Also in 32 bytes, I witnessed some slight improvement. I expected a bit more, so maybe there's some more research to do around the hybrid implementation. It's a pretty new thing. And here I'm comparing all four policies. You can see hardware DCS is really winning in the bigger message sizes. And this is quota somewhat losing, and the hybrid is somewhere in between. Maybe I should have split it into two graphs so you can see better the differences in smaller sizes versus bigger sizes, but the differences are not huge between policies. Eventually, there is a good utilization of networking resources, and the allocation policy almost has no effect about latency whatsoever. It's really almost macro improvement in the difference between DCS quota to hybrid. And I think that's it. Yeah, I think I said, yeah, it looks like the using hardware DCI somewhat helps at the bigger sizes. And in order to really see improvement by using hybrid, you really need to push the system to its bounds. And that's why I didn't use more than 2 nodes. And I think that's it. If you have any questions.
Any questions online? Meanwhile, I don't see any.
I have a question about the performance of all-to-all. It seems like hybrid is sometimes worse than both DCS and software and hardware, right? In some asset sizes.
Is worse than
Sorry, worse than
we're looking at latency, so I think it's not it's worse than hardware DCS here. Yeah, in those specific sizes.
the colors are not very.
Yeah, the
so-
colors are hard to distinguish. Yeah, maybe I can like zoom in or something.
So it means that hardware DCS is better than software DCS in this case?
Yes.
Interesting.
But it really looks like it's happening when we are pushing to the bounds of the machine, because each NUMA node has 128 processors. So no, sorry.
Did you try to run on more than 2 nodes?
No. I was focusing on like the stressed situation.
Okay. I guess we need to review those results. Eventually, we want that hardware hybrid would be better than DCS and software and hardware.
Right.
And this is not the case right now, right? It's kind of like hybrid, I would accept best of the both worlds.
Yeah.
Which is not true, right? Like it's hard to like I cannot tell the colors here.
Yes.
Seems like hardware DCS is pretty much almost always better.
It's hard to say always, because on the small sizes there could be a difference that is not visible.
On the large sizes it gets a bit slower. So what is the status of the code? Is merged? Like I know regular DCS is there.
It's merged. It's in master. There will be probably some more improvements. As for now, for example, DCS quota is supporting some kinds of error handling mechanisms that we're still not supporting in hybrid mode. So it's blocking it from being the default policy. But you can use it, you can experiment with it. Okay, any more questions?
So I have a very high level question, and that's probably more generally on the topic of DC versus RC. Starting from how many processes or ranks would you expect that one should shift from RC to DC?
Depends on the message size. The immediate thing you see with RC is the startup and teardown time that gets bigger because you have to create many QPs and tear down many QPs, even if you're using large messages. But let's put that aside. If messages are large enough, there shouldn't be significant difference, maybe just in terms of memory usage. If the messages are very small, currently the cutoff is about 200 processes. It's not exactly defined like that number, but that's about it according to the performance numbers that we have in place. On newer hardware, I guess the optimal cutoff would be even stretched up till a few thousands of processes. But since RCQ per creation adds quite overhead on init and teardown time, we prefer to keep it at a relatively small threshold today.
Okay.
Any more
other
questions? Not online?
What is the use case for random DC?
It was
you can answer, you see. I prefer you will answer this.
I'm not sure it was clear from Roie's presentation, but one of the problems with software DCS is that you can only post so many operations to the hardware to different destinations before you have to receive new completions in order to post new operations. If you have 32 QPs, you're sending to 1,000 destinations. You send to the first 32, you must get some completion before you send to the next one. So that kind of limits the asynchronous hardware progress that we can do with this transport. You cannot just send 2,000 processes, then go do some computation and hope everything would progress, because it would not. In order to overcome this problem, there is the hardware DCS offload that is available since Quantic 7, when you can post like full queue pair of operations to the hardware, and it could execute all of them, keeping the same scheduling policy as we would do in software. But before that offload existed, it turned out that the best way to schedule operations on DC queue pairs, if we want to do asynchronous progress, is to assign the destinations to random queue pairs. If they are not assigned to random queue pairs, there could be some positive feedback effect that is related to different network latencies of different number of hops that could lead to some increased congestion. In order to avoid that, the random policy was added. But it's still congestion-wise is not as good as DCS.
Okay, thank you.
Any more questions? Online, offline? Okay. If there is no more presentations, I believe we can wrap up for the last presentation for today.